Welcome back to another lecture from organic chemistry. In this lecture, I'm going to go through naming a cyclic alkane. The formula for cyclic alkane, it will be CnH2n versus CnH2n plus 2 for alkane. Okay, so for alkane, when they are linear alkane, that's going to be the formula for them. But if they are cyclic, we will subtract 2 hydrogen from the system. Okay, and how do we name them? Okay, I'm gonna go in count number of carbons that I'm dealing with. I have 3 carbons, so I'm gonna say this one should be propane. Why propane? Because I have 3 carbons and it's alkane. But I want to say this is cyclic, and the term that I'm gonna like the technical prefix that I'm gonna use it will be this cyclo. So we're going to say cyclo in front of each of this compound, and that's going to fix the name technically for us. Okay, because I have 3 carbons. I say cyclopropane, and propane, prop represent 3 carbons, and an represent alkane. Okay, cool. So for the next one, it has a 4 carbon, and then 5 and 6, and I said butane, pentane, and hexane, but they are cyclic, so I'm going to add the cyclo in the front of each one, and as an adjective to fix the name. Okay, so we have cyclobutane, cyclopentane, and cyclohexane. Okay, next, what will happen if we have a hybrid of cyclic alkane and also linear alkane? In that case, how do we name them? And what's the main chain or the parent chain? The parent chain is going to be the one that has more carbons. Okay, and so I'm going to start from wherever they are attached to each other. I'm going to say 1, 2, 3, 4, 5, 6. I have 6 carbons there. Well, for this one, I have 1, 2. So the ring has more, technically, ring has more more carbons, and because it has more carbons, it has 6 carbons versus 2 carbons. We're going to say the ring, it will be the parent. And the 2 carbons at the top, they will be the alkyl or the substituent. And in this case, we are dealing with ethyl. So this one is ethyl. Okay, how do we name it? Okay, start from wherever they are attached to each other and say 1. Okay, so I'm going to say on the first carbon, what do I have? I have ethyl. Okay, YL. Why? Because I want to say this part is attached to the parent. And what's a parent? Parent is a cyclic compound, so it will be cyclo. How many carbons it has? It has 6 of them, so it will be hexane. Hexane. Okay. Do I need to write 1 when I have only 1 substituent? No, there is no really need to write it. So it's completely fine if you just simply ignore the 1 or technically the locator and just simply say, okay, ethyl, cyclohexane, and both cases are correct. Okay. What if you have 2 substituents? In that case, how do you want to actually label them? Or like, where do you start, putting, from where you start, counting technically? I can start from ethyl and say 1, 2, or I can start from methyl and then move in this direction. So the top one is moving clockwise and the second one counterclockwise. Okay, the top one is going to give me 1 for ethyl and 2 for methyl, while the bottom one is giving me 2 for ethyl. Okay. So if I want to write a name for the top one, I have ethyl, okay, and also methyl. Okay, so the priority goes with ethyl. We're going to say we have 1 ethyl. Okay, why ethyl? Because of E. And then on the second carbon, we have methyl. Okay, and how many atoms we have inside the ring? We have 5 of them. That's the reason I chose it as a parent, and that's going to be a cyclohentane. Okay, pentane. Okay. Oh, if I go with the second one, okay, and the name for it, it will be this. It will be 2 ethyl again. Okay, so as you see, I'm giving the priority to ethyl in both cases. And then I say 1 methyl, and then I get cyclopentate. Okay, pentate. Okay, what's the correct what's the correct name, or which one of them is correct? Okay, the one that give the priority to ethyl, it will be the correct one. Okay, in this case, you have two substituents. You have ethyl and methyl. Okay, give the priority to ethyl. Why? We're going to try to alphabetize them, and we will give one to ethyl, because if I alphabetize them, ethyl will come first. So you're going to start from here, and you move toward the second substituent. So the correct answer, it will be the top one. Okay, I have two substituents, and both of them are identical. It doesn't matter from where I start. No, but the starting point it should be, okay, it should be from one of the substituent. Okay, start from one of the substituent, and then you can move clockwise or counterclockwise, and but move in a way that you get the minimum, you get the smallest locator or numbers for the substituent. So I get 1 and 3, whether I'm moving in this direction or in that direction. In both cases, I get 1 and 3. Okay. I have two substituent. Because I have two substituent, I need to have two locators. So keep this one in your mind. Okay. Regardless of how many substituents you have. Okay, if you have 3 substituent, you must have 3 locator or 3 numbers. So each substituent must come with a locator. Because I have 2, so I'm going to say on the first one, comma, and then, okay, why comma? I'm using comma because the second one also is identical to the first substituent. Okay, 1 and 3. I showed where they are located. Then it's a dash, and I'm going to say di. Why di? Because I have 2 methyl groups. Okay, I have methyl groups. And the name for them, we say methyl. Okay, so 1 and 3 dash di. Methyl. And then, okay, name the ring. Ring is made of 4 carbons. Because it's made of 4 carbons, you are going to say cyclobutane. Okay. Another example. I have a hybrid of linear and cyclic alkane, and I want to know what's going to be the parent here, or which one is the substituent. Okay, the ring, it's made of 6 carbons, and if I highlight, like let's say this one, main chain, okay, and you will see that we have more than 6 carbon, and clearly we have more than 6 carbon. I'm going to start, labeling them from left. Why? Because it's going to give me 1, 2, 3. It will give me 3 for the first substituent, or the only substituent we have. But if I start, labeling from other side, okay, if I start from here, I get 1, 2, 3, 4, 5. Okay, 5 for the ring. Okay. And we said, whenever you want to label them in a way to get the smallest possible number or locator for any substituent. So I got 3. Okay, so now I'm going to say on the third carbon, what do I have? I have a cyclic compound. So I go cyclo. And what? It's made of 6 carbons. So say hex. Okay, hex. So on the third carbon, I have cyclohec. I'm supposed to say hexane, but this one is attached to the main chain or the parent. Okay, in order to say this one is attached, we're going to add YL to it. So on the third carbon, we have a cyclohexyl, a ring with 6 carbon that attach to the chain that is made of 7 carbons. And then I'm going to say name of the parent, and it's going to be heptane. Forgive me. Heptane. Okay, and that's going to be the correct name for it. Okay, I have two rings attached to each other. Which one is going to be the parent? The one with more carbon. So that's going to be the parent. And what's the name for it? Cyclopentane. Okay, and this one, it will be the alkyl. Okay, because I'm saying alkyl, that means we are dealing with substituent. Okay, what's the name for this one? It's made of 4 carbons. So you go cyclobutyl. Why L? Because you want to say is attached to a ring with 5 carbons. So let's write it. Okay, we can say on the first carbon, on the first, do I need to write 1 here at all? You don't need to write, but it's completely fine. Okay, so I'm going to say on the first carbon, what do I have? I have cyclobutyl. Okay, butyl. And this one is entire of this piece is attached to a ring that's made of 5 carbons. And it will be cyclopentane. Okay, again, there is no need to write 1, so you can just simply copy this one and say this is going to be the correct name. Okay, if you write it that way and just simply erase the 1, that's 100% correct. So both of them are correct. Okay, if you have 2 or more substituent, always you need to write, like in the locator. But if it's just 1, you can easily ignore it. Okay, next one. I mentioned this one before, but I want to practice one example about it. If you are dealing with a bunch of substituent and one of them or 2 of them, they come with di, tri, or say tert. Okay, so let's list them. If we go with di, tri, or tert, and how about secondary, or you go with what else? Yeah, I think that's it for now. You will not use them. Okay, you will not use them to prioritize, alphabetize, or sorry, prioritize, the substituent. So do not use them. Okay, do not use them to prioritize or order the substituent. The only one that you're going to use, it will be iso. If you have iso, that one, okay, you have to use it as part of the name. Be careful about it. Okay, so now what do I have here? I have tert, butyl. Okay, and how about this one? This one is ethyl. Okay, last one. I have methyl, but I have 2 of them. Okay, I have 2 of them. Remember, we said do not use di, okay, or tri or tert. And so if I want to prioritize them, I'm going to say this one start with B, that one start with E, and this one start with M. So the butyl must come first, and then we have the ethyl, and then the methyl. Okay, we have those 3. Okay, how should I, label them? First of all, we need to know what's the main change. The main change is going to be the ring. This, why? Because it has 6 carbons. So that's going to be the parent. Okay, and how should I label them? Should I start from here? 1, 2, 3, 4, 5, 6, or how about this? 1, forgive me. Yeah, 1, 2, 3, 4, 5, 6, or I can start from here and say 1, 2, 3, 4, 5, 6. If I start from the top, I get 1, 2. Okay, now on the 4th one, here I have 2 methyls. Okay, be careful. There I have 2 methyls, and because I have 2 methyls, I need to say the 4 twice. So I'm going to say 1, 4, and 4. So I get 1244. And next one, I get 1, 2, and then 5 and 5. And last one, I get 1, 1, and then 3 and 4. So what's the smallest number here? Smallest number is this. Okay. When you start, labeling from the methyl groups. So the correct answer, the correct label is going to be this. Okay. You should start from methyl and give methyl 1. Okay. Now, I wrote the answer here for you guys. I said it can be 4-tert-butyl, 3-ethyl, 1,1-dimethyl, or say 4-tert-butyl, 1,1-dimethyl. So I moved position of those two. Okay, I moved position of those two. Why? Because I said D comes before, E. Okay, I'm talking about dimethyl and versus ethyl. And try to, answer this question by yourself. So let's pause the video here, think about it, and see what's going to be the correct answer for it. Okay, great job. So the correct answer for it is going to be this. Okay, we're going to start with butyl. Okay, and why butyl? Because start with B. So we're going to say on the 4th carbon, we have tert butyl. Okay, butyl. And next, on the 3rd carbon, we have ethyl. Okay. Okay, E comes after, B. And next, we're going to say on the first one, again, first one, we have 2 methyls. So we say di, okay? But you're not going to use D to, order them. You have to look for the methyl, and you say methyl. Methyl start with M. Okay, so start with B, E, and M. Okay, and after that one, I'm gonna say I have a ring. It will be cyclo. It's made of 6 carbon. It will be cyclohexane. So that's gonna be the correct name for it. Let me rearrange it. So we got 4-tert-butyl, 3-ethyl, and 1,1-dimethyl cyclohexane. And if I go back, and the correct answer is gonna be this one. Like A, it will be the correct answer. Thank you very much, and I will see you very soon.